Good morning.
Good evening.
And good afternoon.
Welcome to E-door to the world. This is TINA.
And I'm RUY.
Hey RUY, winter break is coming on. Can you think about any fun thing the students can do during the winter break?
TINA, I think we can. There's something on my mind. It's something that we use every day. We know so much about it, but at the same time, we don't really think about it. And if we do, it turns out we don't really know that much about it at all.
What is it? Like we use every day?
We use it every single day. As a matter of fact, our listeners are using it right now.
Sounds interesting. Let me guess. Is it light?
Very similar. Very, very similar. This is going to be electricity.
Electricity? Wow, interesting. But isn't electricity it's a natural resource?
Yes, electricity is a natural phenomenon. Electricity is all around us. It's inherent to matter. And today we're going to be discussing how electricity works, how we use it, and a fun experiment that you can use at home, a good experiment that you can do at home that...
Have fun with it?
Yeah, to have fun with it.
That sounds great. Okay, so first, what's electricity?
Electricity is just, to start talking about electricity, we have to first start with electrons. All atoms are composed of three components: neutrons, protons, and electrons. Electrons are negatively charged, and electrons are just sort of in a cloud floating around the center of an atom. When those electrons move from one atom to another, from one place to another, they create an electric charge. Moving electrons themselves, when they're in motion, that is called an EMF, an electromotive force, or, as we know it, electricity.
Wow, that sounds interesting. So it's it's in the air, right?
It is in the air. So it turns out that all around us, there's electricity floating, flying back and forth. Some of that electricity comes from humans. Actually, much of it comes from humans. All the radio waves that we use, if you're using Wi-Fi, if you're using Bluetooth, if you're using your cell phone, all of that is just electricity moving through the air. And it turns out that you can actually harvest that electricity, but it's a little bit difficult.
Sounds very difficult to me.
Yes, it's a subject that has been talked about and thought about for at least 150 years. If you've ever heard of Nikola Tesla, one of his experiments was trying to use this electricity that's naturally floating in the air, but it turns out to be a lot more difficult than he expected.
What's the name again? What's the name you just mentioned?
Nikola Tesla.
Tesla, so he's the inventor. We're talking, the same name we talked about the last podcast, right?
Yes. So Tesla Cars, Elon Musk's company that makes electric cars, he chose the name of his company from Nikola Tesla because Nikola Tesla is one of the big names in electricity.
Yeah, and I saw a movie before. It's about Tesla and Edison.
Yes, the battle between Tesla and Edison.
Yeah, it's a very interesting movie.
It's very cool. So back in the day, Thomas Edison and Nikola Tesla were both trying to generate electricity and were both trying to sell it. Nikola Tesla wanted to do something called alternating current, which moves the electrons back and forth. Thomas Edison wanted to use something called direct current, or DC. So if you ever heard AC or DC. That comes from alternating current or direct current. And Thomas Edison wanted to sell direct current. Nikola Tesla wanted to sell alternating current. And so that drama played out over a couple of years, maybe a couple of decades, in the United States back in the 1880s. And that drama is the subject of the movie.
So maybe the students can watch out the movies during the winter break.
I think they can. They definitely learn a lot from that.
Great. So next we're going to talk about how do we make electricity, right?
Yes. So it turns out that electricity is at the same time easier than you'd think to generate, but harder to generate too. if you have a moving magnetic field, you are creating electricity.
Okay, so all I need is a magnet and a wire.
Yes. So technically you don't even need the wire, but it's very convenient. We can't really do anything with it if we don't have the wire. So we do need a wire.
Okay.
So what you do is you have a wire, you have the magnet, and if the magnet is moving perpendicular to the wire, so perpendicular means not pointing in the same direction.
So it's like a cross.
Exactly.
Okay, great.
So what we can do, an experiment that you can do, is to make your own generator. And you can do that by taking a wire and winding it many, many, many times, and then moving a magnet perpendicular to that wire.
So you're saying you turn the wire like a spring.
Yes.
So you push the magnet around it, or
you need to move the magnet perpendicular to the direction that the wire is going. So if you have a spring, so imagine a spring in your head. It sort of looks like a circle, maybe like a snake.
Yeah.
That is coiled up. What you want to do is you want to pass the magnet through the center of the coil. And when you do that, you generate an electric field. You generate electricity in the wire.
I have a crazy idea.
Okay.
Can I put a magnet in the center of the spring and shake it?
Absolutely, you can. And that is actually a very interesting way of generating electricity.
Oh, so I need to, if I want to collect the electricity, how should I do?
So that's a little bit more difficult. There are many ways of collecting electricity. Usually when we generate it for an experiment like this, we would just use it right off the bat. So maybe we would connect a light or something like that to your electric circuit so you can see the electricity working. But if you want to collect it, you could use something called a capacitor, which is a way of generating charge, or rather storing charge in an electric circuit to use later.
So in that case, we also can apply this as bicycle, right?
Yes, absolutely. So what you can do in an electric bicycle is you can, when you're pedaling, you're generating electricity, and you can store that electricity in a capacitor. Or right now, what we use is something called a supercapacitor, which is a capacitor that has a huge amount of ability to hold a lot of energy. And then once you're done pedaling, you've stored a bunch of electricity, maybe in a battery if you don't want to use a capacitor. You can stop pedaling and then flip your motor, and then instead of generating electricity, you can start using it to go.
Oh, so it's like right now U-bike, they also have the electricity one. That's the same ideas, right?
Yes.
You have to store the electricity first, then you can use for later.
Yes, exactly. So a really good way of doing this is maybe if you want to bike up a hill, you can spend all of that energy to bike up the hill. But when you're going downhill, usually we only just go downhill, and then we have to use that it's called potential energy. We have to use that gravitational potential energy to convert it to kinetic energy.
I see. So it's like you use it a lot in the daily life.
Absolutely. So if you have an electric car, or if you have, oftentimes right now you have cars that have sort of smaller motors incorporated in them, and they can do something called regenerative braking. So if you've ever heard of the term regenerative braking, that's essentially exactly what that's doing. Instead of using the brakes, because what a brake does is a brake pushes against
the tire
of the car, pushes against the brake pad, and it generates a whole bunch of heat. It's taking all of the kinetic energy of the car, all the energy of the motion of the car, and it's turning it into heat at the intersection between the brake pad and the brake disc. Instead of doing that, what you can do is you can turn on a generator. Instead of taking that kinetic energy and turning it into heat through friction, you could turn it into electrical energy and charge a battery with that.
Wow, that opened my mind. We can do a lot of things about it, you know. Okay, so what about our experiment?
So our experiment, what we want you to do is take A coil of wire, a long coil of wire, maybe 50 meters long, something like that.
50 meter. That's
Yeah.
like 50 meter. That's how long is it? 500 cm?
5,000.
5,000? Wow, that's a lot. 5,000.
That's a lot.
5,000. The wire 5,000 long?
Well, maybe for the experiment we could do a little. How about 500?
500. That's more
A
reasonable.
little bit more reasonable. So what we could do is we can take our 500 centimeters of wire, 500 centimeters of wire, 500 cm. We can make a circle with it, and with the two open ends, we connect them to a light bulb.
Oh, light bulb.
And then what we can do is we can find a strong magnet,
Okay.
and we can pass the magnet through the center, back and forth, very, very fast.
Sounds interesting. Now it's our last part of the show, the most important parts, the question of the day.
Yes. Will you try this experiment at home? And
Or why not? You don't want to try this at home.
yes, or why don't you? Let us know.
Once again, let's review our vocabulary. Natural phenomena, 自然现象。Magnetism, 磁性。Atom, 原子。Electron, 电子。Electricity, 电力。Battle, 战斗。Generate, 产生。Capacitor, 电容器。Regenerative braking, 再生制动。
Please join us on the website to answer some questions and have a chance to earn some great prize. See you next time. Goodbye.